Hello everyone, my name is Rob Higurita and I'm a Principal Technical Account Manager here at AWS and I'm based out of Austin, Texas. Welcome to AWS Supports You, where AWS support experts provide tips to optimize performance in the cloud, lower cost, and provide you with best practices and design considerations. Joining me today is Jonas and Thomas from AWS Support. Can you give us a quick introduction, Jonas and then Thomas?
Yeah, sure. Jonas Bücke. I'm a solutions architect at Amazon Web Services, and I primarily support manufacturing customers in Germany, which is where I'm based, but I also focus on sustainability.
Cool, and hi everyone on the stream. My name's Thomas Attree. I'm a solutions architect based in London and usually support power and utilities customers in the UK, but I've got a specialisation in sustainability as well. It's good to see you again.
Great, and thank you both for joining us, especially a little bit later in the day for y'all being over across the pond there. So today we'll be introducing you all to another topic focused on sustainability, and we're going to specifically focus on optimizing your IoT workloads and sustainability through the cloud. But before we do get into those details today, a quick note to the attendees online. Please feel free to use the chat window on the right-hand side of your screen to let us know where you're joining us from today. And also, feel free to drop your thoughts and questions throughout the episodes. We really do look forward to hearing from you. So we also will provide a link to our survey as well. So if you'd like to let us know how we did, you can click on the link and leave us some feedback. So I'm going to turn it over to Thomas now, one of our experts here on sustainability, to get us started. So Thomas, over to you.
Yeah, thanks, Rob. So yeah, this is the last of Sustainability Month on AWS Supports You. So thank you for listening in if you have been so far. But I'll just run through what we're going to cover today, myself and Jonas, and I'll start off with some real sustainability concepts around greenhouse gas protocol and the scopes and reporting. And then talk about some data that can help support that and the how we can use the cloud to perform those sustainability-focused projects. I'll then talk about a data set or data source for data sets, I should say, called ASDI, Amazon Sustainability Data Initiative. And I'll go through a bit of a demo on how to use one of the data sets that's available on ASDI. And then Jonas will be talking us through some of the operational data sources that we can think of when thinking about sustainability projects and how we can specifically optimize those IoT devices and providing reference architectures for how to do that. So I'll kick off then with trying to get you to think about the full product lifecycle of whatever it is your business does, right? So whether that's a web service or a physical product that you're creating or delivering to end customers. And I want to kind of use a simplified example of a car manufacturer to talk through the different scopes and how they apply. So if we think back to the greenhouse gas protocol, that provides a real holistic picture of how to report emissions that cause global warming. And most businesses report their emissions based upon whether they're scope 1, 2, or 3 emissions, which are outlined in the protocol. So thinking about this from a car manufacturer perspective, I can think that scope 1 emissions, these are direct emissions of greenhouse gases from burning fuel, from burning wood, anything that burns really. So for a car manufacturer, this might come from their facilities. Perhaps it's their factories, their assembly plants, or offices burning gas for heat. It might be their transporters burning diesel for transportation of new vehicles. Scope 2 emissions are purchased energy. So that might be purchased electricity or steam or heat, maybe purchased cooling as well. And that could come from electricity used within assembly lines for our car manufacturer example. And then scope 3 emissions are indirect, both up and downstream, and they're caused by things within your supply chain and then further down the chain in terms of how that product's being used. So for our car manufacturer, that might be their upstream activities like their part suppliers. What emissions are their part suppliers? What emission impact are their part suppliers having? It also would factor in waste from their operations as well. And it would have those indirect downstream activities too, such as the use of the car by the end consumer, right? And how that car is going to be recycled at the end of its life. And all of these scopes can be tricky to report on and to gather all of the information, especially for scope 3. But the key to it all really is data. And that data can come from your operational data, as Jonas will talk about a little bit later. It can come from public data sets, private data sets you might already have, or it might come from commercial data sets as well. So businesses, companies are coming to us, and AWS customers are coming to us with questions about their sustainability projects. How can we start to use our data to report on these scopes? But also, how can we use it to advance us in terms of our other sustainability related goals or statements or signatories that we've committed ourselves to? Whether that's be net zero by 2040, such as the Paris Agreement, for example, or the Climate Pledge, Paris Agreement 2050. How do we bring all of this together? And many customers are trying to break down those long-range commitments into smaller, short-term projects that can create the building blocks for larger goals. And one customer that has worked with AWS and AWS supported their journey on was Volkswagen Group, our car manufacturer. And one of the Volkswagen Group are one of the world's largest leading automobile manufacturers. And they came to the challenge of transforming its business to become a global leading provider of sustainable mobility and to improve their production efficiency by 30%, which is a really considerable amount when thinking about the scale that VW Group operates at. So VW Group needed a flexible, comprehensive, standardized IoT platform to do this so that they could ingest a lot of data and combine all of that data from all of its machines, all of its plants, and all of their legacy applications as well. So Volkswagen and AWS, we've supported them in building what they've called the Volkswagen Industrial Cloud. And what they do from that is basically provide a foundational platform service which spans to the edge, so into their assembly lines, back up to the cloud, so that it can be that data can be swiftly used by other parts of the VW business for the various different use cases. So essentially, for their component production process, Volkswagen have reduced the administrative overhead of collecting and collating that data through automated retrieval, automated reporting, and essentially achieve sustainable improvement of machine availability through transparent activity tracking and knowledge sharing across their different manufacturing plants. And that has in turn increased productivity by having full visibility into production losses and their influence factors. Okay, so if you've been listening to the AWS Supports You stream this month, you will have come across this shared responsibility model with AWS for sustainability previously. But if you haven't, I'll quickly recap it. So in the blue, we have the customer's responsibility of sustainability in the cloud. So this is focusing on how you are using resources in the cloud and how you are maximizing efficiency of those resources that you're consuming. And then in the green, we have AWS's responsibility of the sustainability of the cloud. And that's how AWS is improving the efficiency of our underlying infrastructure, how we're cooling our buildings and how we're building our buildings essentially with low carbon concrete. And also ensuring the electricity supply that's coming in is from renewables. But the cloud gives us an opportunity to capitalize on the scale of the storage and compute platform that previously weren't available to us. So we can use this scale to directly tackle decarbonization and climate change through using huge amounts of huge data sets that previously we wouldn't have been able to easily and efficiently process. And we call this sustainability through the cloud. So like I said earlier, data really is at the core of sustainability practices. And to address really large sustainability problems like climate change, whether that's reporting on your emissions as a business, or whether that's moving you towards being a more sustainable business, or whether that's solving the really big challenges, right? Like, how do we take this carbon out of our atmosphere? What do those climate model projections look like, for example? So we need data to obviously measure the baseline and monitor and manage our changes towards our goals that we've set ourselves in terms of sustainability. But there has been in the past, well, there is now too much data. It's dispersed. It's in different formats. It's being used by users with different levels of expertise. You've got different tools available, and there's different requirements across all of those tools and formats as well. And that data might come from a lot of different sources, like the operational data that Jonas will cover, public data sets that are available, maybe from government entities, and we'll see a couple of those later. Maybe it's a commercial data set that you need to buy, all through a couple of programs like AWS ADX, Amazon Data Exchange, or ASDI, which is the Amazon Sustainability Data Initiative. And I want to talk to you a little bit about ASDI a little bit more. But before we do that, I'm happy to break for any questions if there are in the chat, Rob.
Hey, Thomas. Thanks for the information you shared so far. So no questions from the audience. So audience, please make sure to take a look over on that right-hand side of your chat window and feel free to post your questions here today. I did have a question, though, kind of on what you're kind of iterating through the different data types and such. Does AWS support customers in the ideation in this sector for sustainability, or do we provide any help there?
Yeah, absolutely we do. So at Amazon, we have what we call the working backwards process, which is where we take what the customer really needs, right, and work backwards from that by producing what we call a press release FAQ. And we have the working backwards process can be walked through collaboratively with your AWS account. But we also have a couple of additional initiatives, such as the innovation workshops, where we can come and work with you to develop minimum viable products and proof of concepts quite rapidly with your teams to understand what it is where you want to get to and how we can get there. Yeah, they're probably the key initiatives we've got there in terms of supporting customers. We've also got ProServe, professional services team, that can help come and build that with you as well.
Cool. Yeah, thanks for the additional information. I appreciate that. So, an audience, please make sure if you've got any questions, go ahead and post them in the chat here, and we'll ask them at our next break. But for now, we'll go ahead and turn it back over to you to continue on through.
Cool, no problem. Thank you very much. So, like I mentioned, I want to talk to you a little bit about the Amazon Sustainability Data Initiative and what that is all about. So, the Amazon Sustainability Data Initiative essentially hosts a broad variety of data sets to make it really easy to collect and use that data within your own projects. So whether that's weather data or satellite imagery data, like we can see on screen from the Landsat 8 satellite, whether that's biological data or anything else within the initiative itself. And what it really does is allows you as customers to get started without that added burden of having to go and collect that data yourself, maybe go and talking, building those relationships with the entities and authorities that have provided that data yourselves in order to then ingest it, then go and store it. Some of these data sets are enormous, so the cost of storage is often a big barrier to entry as well. So one example there is the Landsat satellite imagery, like you can see on the slide. It's available for free from NASA and the US Geological Survey, but to use it in an application, typically you would require downloading it, storing it in the cloud, and then perhaps cleaning and organizing it to make it more easily accessible to your application. And that can be really time consuming. It can be quite expensive. And satellite data sets can be gargantuan in size. So running into petabytes, right? It's a lot to store and a lot to process. So by using the free Landsat 8 dataset hosted on AWS, customers can offload all of that work onto us. And we've recently integrated in the last couple of weeks, we've integrated the Amazon Sustainability Data Initiative datasets into AWS Data Exchange. So if you've not checked out AWS Data Exchange, I encourage you to go and have a look. But it's a really cool service to integrate and to integrate and use and utilize third-party data sets. There's more than over 3,000 different data sets on there available from over 250 suppliers. So go and check it out. Make sure to see if there are any data sets within there that you can use to complement your own projects as well. That data within ADX, that can be downloaded as through files, or it can be accessed through APIs directly to S3 buckets that are hosted in ADX as well. Or it could be utilized through Redshift queries, Amazon Redshift queries as well, directly into your applications. So there's a lot on there, and I really encourage you to go and take a look. So really focusing deeper on the ASDI, and the real mission of ASDI is to reduce the cost, the time, and the technical barriers to extracting knowledge and insights from really large data sets. And so AWS, using AWS and its scalable infrastructure, all of the storage and compute that I mentioned earlier, that really can help us address this problem by advancing innovation in the space of sustainability and climate change. And through ASDI, we also provide some cloud grants to democratize access to that data and the compute for innovators and researchers in all geographies, and to use that data for their climate change mitigation strategies and actions as well. So if you think you're working on a project that fits that criteria, come and talk to us. We may be able to help you out with a grant there. Okay, so some examples of the authoritative data providers that contribute data to the ASDI. We bring these bringing these resources to the cloud is a win-win-win situation, right? You probably recognize some of the logos on the screen there, maybe from NOAA or from NASA, certainly, and from the UK Met Office as well. And ASDI really helps those data providers, supports those providers themselves by improving the awareness and dissemination of that data amongst AWS customers. And it encourages the use of that data by really making it easier to adopt and access it, and co-locating it with compute resources in the cloud as well. And it decreases the need for that IT infrastructure on their side to make that available and publicly available for individuals to use. And it helps users because they no longer have to take on the cost of discovering the data, accessing it, acquiring it, storing it, and cleaning it. And then it provides you as an AWS customer with access to data that you need to perform your work and answer the questions that are pertinent to your sustainability projects. I'm going to show you really quickly now how an ASDI data set can be used. And I'm going to show you with a SageMaker notebook. If in the back end we could just get the video up. Fantastic. Great. So the data set that I'm going to be using is called the CMIP6 data set, the Coupled Model Intercomparison Project 6. And that sounds quite big, but I'm going to break it down. It sounds quite complicated, but I'm going to break it down. So this data set contains the 6th phase of Global Coupled Ocean Atmosphere General Circulation Model Ensemble. So I'll break that down again. What it contains is climate simulations, climate projections of what our climate might look like in the next 100 years. And climate institutions from all over the world run their climate models in a prescribed fashion to be able to intercompare the results within the same model. So these simulations are then analysed to enable the understanding of what future climate might look like under various different scenarios. So what we're looking at here are projections of what the future climate might look like. So I'll demonstrate how to work with the data using Python and Jupyter notebooks in a SageMaker notebook environment, and demonstrating how easy it is to connect to data sets hosted in ASDI. So going to my Jupyter Notebook tab, you can see that I start off by importing some necessary packages to work with the data. And next we intake the open next we use intake to open the dataset catalog from the ASDI S3 bucket. Then we define a number of variables to narrow the search for the simulation data we're interested in. And then performing a search of the catalog object we created earlier, this outputs a collection of data sets that we're then going to download and combine. And these data sets are, the data sets are downloaded from the URL in the ZStore column in the table that you can see on the recording there. So once combined, we then normalize the air temperature into degrees Celsius. And next we can apply or perform an analysis to plot just one of the climate scenarios. So when we plot this climate scenario, we plot the SSP 585 scenario. We actually looked at 5 in the table above. And what this shows us is the temperature difference from historical data in 2015 to a projection in 2100. And what I find really quite cool with this this plot is that you can make out the land masses of South America, North America, Australia, parts of Asia, but this map or this data doesn't contain any land border information or vectors of country borders. This is purely just how the data is represented, and it's the difference in the thermal absorption properties of the sea versus land mass. So pretty interesting little plot there. But that's just plotting one projection. But what we can also do then in the second analysis here is take a look at one location. So I've picked London, and we can basically plot a time series of the historical surface air temperature along with 4 future scenarios in our data set. And we can see that the upward temperature trend in the simulation model ensemble plotted on the graph here. So we can see that in red, this is our historical data observation data that we've got in the data set. And then the blue, the green, the orange, these are our simulations, our climate simulations. So you can do a lot of work on this data. The main point to get across here is that you can do a lot of work on this data, but really all you need to do is point it to that public S3 bucket, and the data can be accessed directly from there for the CMIP6 data set in particular. If we go back to the slides, I'm happy to break here just for a question.
Hey, Thomas, thanks for showing us that info and demo of kind of how to visualize this data. It's kind of cool to see all that information there. Did have a question that came in a little bit ago from the audience here from VNEMMANI. Sorry, I didn't want to butcher your screen name. Was there any preferred file formats that AWS recommends or for most of the services to use?
Yeah, that's a great question. So there's no preferred file format, and depending on the type of information or data that's available, especially in ASDI, depends on the type of file format that it's delivered in. So a lot of the data sets are delivered in Parquet, or in CSV. It really depends. Some of the imagery data sets are obviously stored in a bitmap format as well, often GeoTIFF. But it really depends. That for climate data in particular, often that is quite multi-dimensional. So multi-dimensional array data is best represented in formats like NetCDF. So there are some more specialist data formats in there. So there's no one size fits all answer there. It really depends on the type of data that you're consuming.
Great. Okay. Thanks for that additional information. I'll drop a link too, just in case you're looking for a little more generalized information. We did the previous episode with Katya and Luis that had some optimized for kind of storage and stuff for sustainability as well. Okay, so I'll drop that link into the chat as well for everyone. But otherwise, I'll turn it back over to you to continue on through the rest. Thank you. Super.
Thank you. Okay. So hopefully by now you've got a bit of an idea of how to report. What reporting means in terms of climate, in terms of carbon reporting, but also where to think about where data can come from to help inform that, and also where data can come from to help inform your climate or sustainability related projects to support your sustainability goals as well. And so I just wanted to finish off with a call to action, really, for all of you builders out there listening in on the stream. Please, I believe we've shared the link in the chat. Go and check out the available data sets in ASDI and the wider ADX data sets as well. Go and have a look, see what's available to you. They're free to use, so go and have a look, especially the ASDI data sets. And start thinking about how you can integrate some of that data into your own sustainability projects. And once you've done that, once you've checked out some of the examples that are coupled with the data sets themselves, share what you've learned. Share your findings with us. Come and talk to us about it. Write a blog post with us. Share the great work that you've done and what you've found and how you've integrated that data into your own goals with us. And let's really get talking about it, because sustainability really is everyone's responsibility. Not just isolated to a number of individuals. Great. So I'm going to hand over at this point to Jonas, who's going to be talking about optimizing IoT devices for sustainability. So Jonas, over to you.
Cool. Thanks, Thomas. So yeah, for the second half of the presentation, we are going to take a look specifically into the Internet of Things, so IoT. And yeah, back to Thomas was talking about. So we have commercially available data sets using AWS Data Exchange. We have free data sets available using the Amazon Sustainability Data Initiative. But in order to make those kind of like contextualized decisions, local decisions, let's go back to that car example. Yeah, I have an individual car, and yes, I can use an external data source for like angle of descent of the area that I'm traveling, for map information, for weather information. But I will also need the specific information for the area of my car. So what's the distance to other vehicles, for example? Same goes for factory operations, for buildings, for farms where you have specific devices that measure soil information, etc. And I can combine those data sets to then aggregate them, make a localized decision based on what's actually happening at a specific place. And this is where we use IoT. And IoT, in my definition, meaning that we have a remote location. Yeah, it's not in the cloud, it's not somewhere central, but we have some specific place where we want to measure something, pre-process something, and then act upon it. And at this place, we install some piece of hardware. It might be a microprocessor, might be a microcontroller. It's running some embedded software, and yeah, the software is then interacting with local sensors or local actors, and yeah, gives us some type of value. And if we move on to the shared responsibility model that Thomas was showing you before, this also goes into the direction of sustainability through the cloud. So we leverage the Internet of Things, we leverage AWS IoT services to gain a specific value in the area of environmental sustainability, either improving energy efficiency or reducing carbon emissions, for example. And I would like to separate my presentation into two subparts. If you remember Thomas's agenda at the beginning. So the first section is, okay, how do we actually support customers in the area of sustainability with AWS IoT services? And then the second half is about optimization. So if you've listened into the past talks, you've just mentioned it in one of the QA sessions. So we had a general session on optimizing storage, optimizing networking. We also had a session specifically on optimizing machine learning workloads and AI. So for the second half, we'll take a look into optimizing IoT workloads and specifically how you can optimize the device itself. So yeah, first of all, I'd like to get started with some use cases. So the first brand is one that you might be familiar with. It's Coca-Cola. In this case, it's actually Coca-Cola in Turkey. Turkey has a local subsidiary of Coca-Cola, which is the 6th largest bottling subsidiary globally. They have, I think, 26 sites in Turkey. And when we started supporting them, engaging with them, they still had a lot of manual processes in the area of how they collect data in their production plant, on their production line. And most specifically, they also had this CIP process on the top of the slide, this clean in place process, meaning that once per day, the production line has to be able to clean itself to comply with high quality and high hygiene standards. And my camera is doing a bit of a weird auto-focusing thing right now. So what they were doing is they started using AWS IoT. Specifically, they went on and modeled their entire production line in the cloud as a digital representation of their line. And they did this using a service called AWS IoT Sidewise, which is a service that allows you to monitor, model, and create alarms based on industrial equipment at scale. So in this IoT use case, our remote location is the factory. And then we have a central location where we aggregate sensor information of the factory, of the production line, and act upon that. And the remote management interacting with local sensors was done with a second service called AWS IoT Greengrass. This is a service consisting of an edge runtime and a cloud service. And in combination, those allow you to build, deploy, and remotely manage device software. So what was the result? Well, they improved their cleaning in place process. And this resulted in a 9% overall annual water consumption reduction, as well as a 20% energy consumption reduction. Now, if we look into another example, which is Weisberger. Weisberger belongs to Anheuser-Busch InBev, which is one of the largest breweries in the world. And they focus on also IoT analytic solutions in the area of the foods and beverages industry. And they built a solution to not reduce water or energy, but actually reduce waste, eliminate waste. And in their situation, the edge is not a factory, but it's a bar, so the place where end customers are getting served their beer. And they also added sensors, added a gateway device, and overall they achieved a 45% reduction of waste. Also using AWS IoT Greengrass, so the service we just heard about, but also using a service called AWS IoT Core. And I'm specifically highlighting those because they will be important in the second half of the session, where we actually talk about optimization. And AWS IoT Core is like a central hub. Yeah, this is the place where all of your IoT devices register, and IoT Core will then take care of validating device certificates, for example, attaching or associating an IoT device with a security policy that handles, okay, how is actually this device allowed to behave, and how it is allowed to exchange information with cloud resources. And AWS IoT Core generally takes care of the topic of security, so making sure that all of the data exchange between an IoT device and the cloud happens using mutually authenticated TLS encrypted traffic. Yeah, and for the third example that I've brought, we'll take a look into a customer in the energy segment, which is Tibber. They are located in the Nordics, have expanded to multiple countries by now, and they built a solution for smarter energy management for their end customers. So in this case, the edge location is my house, because I have a smart appliance that again runs AWS IoT services. It's located next to my meter that I have at my home. And Tibber will understand how much energy I'm consuming throughout the day. And it's also allowing me to associate specific energy spent with specific tasks that I'm doing, like energy intensive tasks, typically, like heating my home or charging my car. And then Tibber will directly purchase this energy that I'm using from the spot market. It tries to maximize renewable energy procurement for me, and also gives me recommendations. For example, I might charge my car at another time. And by doing so, I can actually achieve a higher utilization of renewable resources in my personal energy mix. And they also built this on AWS IoT Core. They also built this with analytics services, because they have a large analytics platform in the cloud that is then doing all of the data analysis and procurement decisions. And they both reduce energy consumption of the end customers, as well as reduce their energy bill by up to 20%. So if we take a look at all of those cases, so if we move to the next question, in the next step, we should think about what this actually results in. But before we do that and move on to the second part of the section, I would actually ask if there's any question that we should answer.
Hey, thanks, Jonas. Appreciate the information, all the case studies you kind of shared with them, especially on the Weisberger one. But also in the Coca-Cola case, does their new IoT solution also help them in more accurately reporting resource consumption and like emissions and such as well with their supply chain to regulators?
Mm-hmm. Yes, it does. So if you remember Thomas's part at the beginning, where he was talking about the greenhouse gas protocols and its individual scopes, this is, of course, just one part of the picture, but yes, so this solution now helps Coca-Cola to actually have detailed data available on their exact energy consumption for their steps of their production line, as well as on water consumption. And yes, this is an important piece of getting this factory operations data into their sustainability reports. Yeah.
Wow, great. That's good information to add there, so I appreciate that. So no questions from the audience right now pertaining to what we're talking about. We're currently talking about some AWS certification items, but I'll let you continue through. And audience, please feel free to post your questions about sustainability items here as well. So thanks, Jonas. Appreciate it.
Cool. So yeah, so why I left this question on is, so if we have all of those customers that now look into IoT technology in general, yeah, throughout the global economy, and we will hopefully see many more customers leverage IoT because as we just saw, we can achieve quite some significant efficiency gains, resulting in more sustainable solutions. But the origin of also a blog post we were writing on this in the end of last year, early this year, was okay. So how many devices does this actually result in? And we did a bit of a quick Google research and in the internet, and we found varying numbers between like 16 billion of devices in the global field by 2025 to 25 billion devices to 75 billion active IoT devices in the global field by 2025. And well, this got us thinking for this next session, because at 75 billion devices, this is a level of scale where it's not just IoT itself that helps us make a process more sustainable, but this is a level of scale where it's important that we also consider the solution itself. So similarly, as we spoke in the last weeks about, okay, how can AWS help to make a machine learning workload more sustainable, make a general workload in the cloud more sustainable? Yeah, with 75 billion devices, we should also make those devices more sustainable. And this is what the second section is about. And to put this simply, I mean, we have a two-sided solution in the area of IoT. So we have the cloud side of things where we have our cloud services, we centrally aggregate data, we have some maybe data lake that stores the data, and then we have analytics tools that allow us to run various analyses, train a machine learning model, run an inference, etc. But then on the left, like on my imaginary left side of the diagram, we also have the edge side of things. So we have a hardware device that's somewhere in the field, and also this side has to be optimized. For the right-hand side, for the cloud resources, we shared a lot of things. So we also have, for example, a sustainability pillar as part of our AWS well-architected framework, which is our body of best practices, subdivided into 6 different pillars by now, that provide you a lot of different information how you can make your AWS architecture more sustainable. But what we also want to have is we want to leverage cloud efficiency and cloud carbon reduction at a remote location. So what does cloud efficiency mean? This is also a recap. So if you listened into past cadences of this month's streams, you will be familiar with the slide as well. There are a couple of reports, from 451 Research. They are part of Standard & Poor's S&P Global, and 451 Research evaluated typical enterprise data centers on premises with the AWS cloud in various geographies. And this is the 3 reports that we have, one for the US, one for Europe, one for Asia Pacific. And we've also have those linked and shared in the chat, so feel free to check them out. I just want to give the quick overview. What's the gist of it? Well, with the higher renewable energy ratio, with the more efficient hardware, the more efficient tailor-made service, with the services that we build on top of it, we can achieve significant efficiency gains. So in the subheading, you can see those numbers for Europe. In Europe, for example, to run the identical task on premises versus running it in an AWS region in Europe results in an 80% carbon reduction just for running the same task. And Thomas mentioned before, by 2025, we will run our global operations, or we are on a path to run our global operations with 100% renewable energy. And by then, this will be a 96% carbon reduction. So, and somehow we also want to leverage this at our edge device, which is obviously not running in the cloud, but is closely connected with the cloud. So there might be some way how we can actually leverage those efficiency gains at our remote location as well. So if you move to the next one, this is actually very thought about, okay, which device properties do we see? So if we design an IoT solution, if we design a piece of hardware, and have some architectural decisions to make, some trade-offs to make, what would be properties to go for? And we ended up with 3 of them for now. Also, this is something where we, of course, always are happy for our customers' feedback. So how others see this, which things are more helpful. And yeah, the 3 that we ended up with is actually lean devices, efficient, and durable devices. What does this mean? Well, for lean devices, this means exactly what we saw on the previous slide. We want to keep our edge layer as minimal as possible. So we can run necessary components locally. For example, I need to interact with sensors. I need to interact with actors. I maybe have some latency critical local computation that I absolutely have to make. But for example, once per day, once per month, I might run like an extensive, complicated analytics job. I should not run this on a device. And even if it's just a bit more complicated job, if it is not latency critical, if I can run it somewhere else, I can leverage cloud resources where I can spin it up, I can run it, and I can decommission my resources as soon as my computation is complete. This allows me to use less materials on my device, right? I can put less CPU power into it, less memory, less local storage, as well as less material usage overall. I mean, this also goes in the direction of saving environmentally hazardous materials. We have plastics, we have rare earth metals that we can save on if we reduce the amount of resources that we have to put in ours, up to 75 billion active IoT devices, where this will really make a difference. Next one is efficiency. For efficiency, well, building an embedded device software, flashing the firmware on a device and deploying it somewhere is not the end. This is actually the beginning. And from there, we want to understand how does the device behave? Is it necessary that we read a sensor once per second? Would it be fine to read it once per minute? Is it necessary to do a specific computation at all? Or can we just ingest the data as the sensor is providing it into a central location? And those are the things that we will always understand better and better over time. As our end users use our application, we can see how they use it and how we might optimize for that. So it's crucial that we can, the keyword is here, over-the-air updates. Yeah, we can update how our device behaves, how we work with data, how we upload data. And this is the second one. The third one goes into a similar direction, also about business logic flexibility, but this time more from a maintenance perspective. So if I install a device somewhere, this is a significant one-time effort because I have to produce the device, I have to transport it to some location, I have to maybe need an engineer that initially sets up all of the components, and at some point I need to dispose of the device when its usage lifecycle ends. And this one-time effort of carbon emissions gets relatively seen lower the longer I can actually use the device. So the last point is, let's make sure that we can manage and change how those devices work. Of course, not possible on a hardware level, but on a software level. So what's the data format that we use? Which data points do we read? And also remote management, monitoring, maintenance. So if something breaks, do we have to send the device in? Let's go back to that car example. If the car breaks, do we have to send it back to the dealership? Or can we do some remote maintenance, understand some diagnostics data, understand what the problem is, maybe solve it remotely if it's software related, otherwise at least pin down the exact problem and then do some efficient and targeted maintenance for that. And yeah, we also thought about, okay, how can we translate this into an actual AWS architecture? So for the next slide, you will see an example. So this is not our IoT solution from before, but this is actually using AWS IoT services to optimize the device. So on the left-hand side, you see that IoT edge side of the picture. And on the right-hand side, you can see the cloud side of our solution. And we have 3 different sensors. We have a thermostat, we have a camera, and we have a coffee pot. And we also have some software components that interact with them. Now on the right-hand side, we manage this data exchange to the devices on the left. We have some cloud resources that we could potentially leverage. And we have additional management capabilities like device management capabilities, device protection capabilities. This is intentionally not AWS service specific yet. So we have services for those components, but quite often we also have partner services for those components. So we have an extensive AWS partner network. And for example, in the areas of a local edge runtime, there are also other solutions that integrate very well and serve that purpose of making, for example, over-the-air updates possible. So if we move to the next slide, this is actually like the version of it with AWS services in. And yeah, you will see some familiar names from before. So we can use AWS IoT Greengrass to remotely manage device software. This will allow us to perform over-the-air updates. So achieving this device property of efficiency. So we can change the behavior. We can change the business logic. We can change how we upload information. We can change how we store information. Next up, we have AWS IoT Core. AWS IoT Core is our means of achieving the lean device property. Because with AWS IoT Core, we have an integration using AWS IoT Core rules, topic rules, that allow us to integrate with various different AWS cloud services. And yeah, this allows us to exchange messages with the cloud and the device and run computation centrally and then return results back to the device instead of having to equip it for peak usage and build a device with more computational power that I don't actually need 90% of the time. And finally, if you look at the top right-hand corner, we have AWS IoT Device Defender and AWS IoT Device Management. So AWS IoT Device Management is a service to manage, as the name suggests, manage devices at scale, while AWS IoT Device Defender analyzes and audits IoT devices. So it understands their behavior and it understands also anomalous behavior. So is a device performing in a very strange way? Well, AWS IoT Device Defender can raise an alarm for that. And this addresses the third device property, which is durability. So if we have remote management insights, if we have remote monitoring data that we can centrally aggregate and understand, compare also from a security perspective, this will make our maintenance processes much more efficient. And for example, in the case of AWS IoT Device Management, there's also a component called secure tunneling. This allows you to build a remote tunnel, establish a remote tunnel connection to a device from the cloud. So I, as an operator, I can locally run diagnostics without actually having to be on site to do those types of tests. So summing all of this up, this is the device properties again, this time with those solutions and approaches that I just mentioned, as well as the services that could help with that on the right. So we can achieve lean devices. Yeah, let's keep those edge layers as thin as possible, only run what's needed locally, and make sure that everything that is not latency critical, of course, runs centrally where it can scale and be decommissioned as soon as we are finished with our computation. Efficiency, yes, over-the-air updates. Let's make sure that deployment of device is actually the first day of operations and not the final day of building the solution, meaning on an ongoing basis, we will work on understanding the device's behavior and optimizing it over time to make it more and more efficient, or more and more efficient depending on the user pattern. So how our end users, how our analytics solution, for example, actually works with the data that the devices collect in the field. And finally, durable devices. Yeah, let's make sure those devices are remotely manageable, remotely monitored, and have some diagnostics capabilities that we can leverage. So we don't have to bring the device in to the manufacturer, for example, to a specific operations team, but we can just, as much as possible, at least, update them, update them and make those adjustments to fix a potential issue without having it to transport at the central location and cause those additional emissions for this type of maintenance procedure. And at this point, I would like to give you another break for questions. Let me know, what do you think of this?
Hi, Enes, thanks. No questions from the audience, but I did have a question. If we go back and look at the diagram real quickly, there was a couple items mentioned as shadow. And I'm just kind of curious what exactly shadow is and how would I use it to exchange a state with other AWS cloud services? If you could kind of explain a little bit there.
Yeah, sure. Yeah, this is one component that I didn't cover while explaining the diagram. This shadow suggests a feature of AWS IoT Core, which is called an AWS IoT Device Shadow. And this is like a digital state representation of a device. So if my device is measuring temperature, it's measuring position, it's measuring a specific state of specific tasks that it's running, I can have all of this data being kept up to date in a state. And so I don't have to individually upload individual data points, but I can act upon a state and trigger an event as soon as something happens, changes with the state, and act accordingly. Change then the state to some other value from the cloud side, for example, to activate a specific task, to send a command down to the device. So this is like a central repository to manage metadata of the device's state.
Okay. Thanks for explaining that a little more in depth here. So appreciate that, because I'm not an IoT expert, and so I'm hoping that helps some of the audience as well. So I appreciate it. I'll turn it back over to you for anything else you have left for today.
Yeah. Thanks. Yeah, actually, I just have some closing remarks now. So first of all, similarly as with Thomas's part on the Amazon Sustainability Data Initiative, on AWS Data Exchange, when you're planning sustainability solutions, keep those principles in mind, right? Keep those device properties in mind. They are not a yes or no activity, right? My device is not lean or it's not lean. It's or it's not efficient or inefficient, but those are destinations, goals to work towards. So if I make an architectural decision, I can make a directionally correct decision to make my device more efficient, more durable. And we should include those thoughts into our entire design process. So other than that, we have further reading material. So we have the blog post that I was mentioning, but we also have data and information from Amazon devices. So for example, Echo devices. So how do we actually model emissions with our Echo devices? How do we work to make our devices as Amazon more sustainable? And there's materials on that we publish online, and I also linked that on the slide. And finally, from a technology perspective, we mentioned the AWS well-architected framework and its sustainability pillar. Run a review. Check whether your architecture complies with those best practices. See if there's anything where you can optimize, where you can make your solution just a bit more sustainable. And also we have information. This is something that Thomas was mentioning in the first question section as well. We have materials and our approach, our working backwards methodology on sustainable business innovation as well. So we've also linked something there too, so you can get to those ideas that that will help you build sustainable solutions. And with that, this is everything from my side. So thanks a lot.
Great. I appreciate it, Jonas and Thomas, for sharing everything that you did today. And thanks, everyone, for joining us for this month's worth of sustainability items. But today, we specifically looked at, of course, how we optimize our IoT usage through the cloud. If there are any questions that were not answered today, you can post your questions on a repost at AWS, where one of our experts can provide you with an answer to your question, and it could even become a topic of one of our future shows. If you have feedback for us, please check the chat box on the right hand for a link to our survey, where I'll post it again here in a minute, or you can email us at awssupportsyou@amazon.com, because we really do want to hear from you and let us know what else you would like to see on the show. So just a heads up, next Monday we will be off for the 4th of July holiday. But please join us on Tuesday, July 5th at 11 a.m. Pacific, where we'll be discussing building an effective operations ready review here. So thank you for joining us at AWS Supports You, and happy cloud computing, everyone.